finite automata into its equivalent regular expression. This is the finite automata what they given in the question, and we need to convert this finite automata into normal regular expression. See guys, the first step what we need to note down is the first thing, note down for the q naught. What is a q naught? This is the initial state. So I wrote it here, initial state. Then see guys, the next step is whether we need to check is there any incoming edges or not. For Q naught, there are no incoming edges. Incoming edges means the edges which are reaching the particular state. That means we are taking the Q naught. So the edges which are reaching the Q naught, those are the incoming edges. It doesn't have any incoming edges. It just have the outgoing edge. So no incoming edges. If any state doesn't have any incoming edges, then simply take the epsilon in their place. So we can't able to leave them single. So simply take epsilon. This is the equation 1. Then next consider for Q1. Q1, what is meant by Q1 here? Q1 is the final state. Check how many incoming edges it has. See guys, from Q naught it has 0 and 1. That means it has 2 incoming edges from Q naught and 1 its own self loop, that is with 0. So how many incoming edges? 3 incoming edges. Those are the 3 incoming edges. Q1 equals to, while writing here we just need to add them. See how to add? I will say here Q1 equals to, just write the edges from where it is coming. 0 from Q naught. 0 Q naught plus and another edge 1 from Q naught. So then the third incoming state is, edge is from 0 itself. So 0 Q1. 0 Q1. The same thing I just wrote here. Let us consider it as a step 2. Then next check for Q2. Q2 has 3 incoming edges. See guys how? From Q1 it has 1 and for itself it has 2 incoming edges. So write them here. How to write? 1 Q2. So 1 Q2 plus 0 Q2 plus 1 Q1. So from 1 it is coming from Q1. So write here plus 1 Q1. Consider it as a third equation. Then the next step is we need to check here only for the final state. Q1 is the final state. Check for final state only. Here, what's the final state equation we have? 0 Q naught, 1 Q naught, 0 Q1. Q naught, Q naught, Q1. Guys, just here remember that Q naught is 2 times it have. That means we can take it as common. 0 plus 1 plus 0 Q1. In place of Q naught, what's the value we have here? Epsilon. Just substitute it here. Here from equation 1. That is epsilon of 0 plus 1 plus 0 Q1. If we have epsilon or not, just we will take that 0 plus 1 plus 0 Q1. This is the equation. Now let's see here guys. I think you already knows the Arrhenius theorem. What is Arrhenius theorem guys? R equal to Q plus PR. Then what we need to write that? R equal to QP star. This is the Arrhenius theorem. Let's implement this theorem here. How to implement that? Let us consider that this is the R. Then what is this? Here the same R value we need to get. Here it is the R. Then here what is here guys? P we have. Just assume it as P. Then what is meant by Q? The remaining thing whatever we may have, we just consider it as a Q. Now it is in the form R equals to Q plus PR. Then into which form we need to write that? R equals to QP star. That means Q1 in place of R. In place of Q, that is 0 plus 1. Then what is meant by P? 0 and asterisk 0 asterisk. This is the required equation of regular expression. This is the regular expression what we got. It means what we want. See guys, it is very simple. First of all, we need to write that what is meant by initial state and what is the final state and how many incoming edges it has. Those many incoming edges we need to represent here. Representation of incoming edges is more important. Then just substituting the values from the above equations into the equation what we has. It is a final state equation. Then at last we just need to compare it with the Arrhenius theorem and we need to get the regular expression. So I think you are understood this guys. If you have any comments, then comment in the comment section. Let me know. Thank you for watching my video.